All right, now we're really going. There's two reasons a test will fail. One, your test is bad. You wrote a test that was incorrect. Imagine on the first line I wrote 6 equals broken abs of 5. Well, that test would fail, not because there's anything wrong with the function I wrote, but because the test was wrong. But those mistakes usually happen just because I just messed up writing the test. The other reason a test could fail is your function's wrong. Clearly, we can see this function called broken absolute value is a broken absolute value. All it does is return x. So this function will be correct 2 out of the 3 tests, but that one test, it's going to fail because, well, it's wrong that one time. And it's good that we caught it. We want to make sure our tests, I think I asked this last time. The reason I picked these 3 values is I wanted a positive number, a negative number, and 0, because 0 is kind of like a funny little middle case. We want to have, in our tests, we want them to be as comprehensive as possible. Cover as many cases as you can. Now, if it works for positive 5, I have no reason to believe it's not going to work for positive 6, right? That would be not silly, but when I look at my code and I know it passes for positive 5, it should pass for positive 6, so I don't need to test the positive 6 case. Think of the cases more general. But I will say, knowing what cases to cover, it's not easy. It's a bit of an art more than a science, right? You just kind of learn the intuition, and you get experience as you go, and you get a better sense of what should and should not be tested. But, just try to think of the different various cases. But this one fails. And it should fail because, well, the function's wrong. When assert is run, notice assert isn't asserting that 5 equals broken abs of 5. Assert really only cares about true or false. So if the expression on the right evaluates to true, the assert's happy. And if the assert is happy, it says nothing at all. If the thing on the right-hand side evaluates to false, it'll say assert false, and then, well, the program will crash. So that's a good thing, because it's better for a program to crash when there's a bug than for it to run and we'd think everything's okay, but it's really not. So only when it's false will you see something. If you write a bunch of tests and you hit run and it's not saying anything, that's assuming everything's working correctly, right? That's a good thing, right? It shouldn't say anything if it's happy. And then sum of squares. Here's an example. We talked about this one on Friday, right? We talked also why we had to do that absolute difference thing. I'm seeing only one person nod. More people nod? Okay, so we did. I hit run. It doesn't say anything. Yay, right? Now, imagine I have a bunch of functions. Imagine you're looking at assignment 1, you have a bunch of functions, and you hit run, and every time you hit run, it doesn't say anything. But it's possible someone can come along and say, maybe they accidentally, turn that to an A. The tests are handy because every time you run your code, the tests always run, meaning if anything changed such that the function was wrong, well, the tests are there to always ensure that it's right. So if the function changes, we can still confirm it's correct with the tests. We don't just write the tests and then once it passed, we remove them. No, you leave them in there. And then there was this whole thing. I'll say this again quickly. It's not safe to ever use equals on floating point numbers. That's because computers suck with floating point numbers. So the trick is you take the difference between the things you want to compare to check if they're equal. And if their difference is really little, we say, OK, good enough. Now, how little should that be? It's up to you. Depends on what the application area is, right? This is what I was saying last time. If it's for like calculating how far it is for me to get from work to here in kilometers, that's absolutely more than enough. If it's for the space station, maybe we want more precision. Yeah, blah, 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 yep. Now here's another one. Here's more tests, right? And I've tested various cases. What do I have? I've got, well, 0, -40, -5, 30, and I checked some decimal value stuff as well. Great. So there is my test for Celsius to Fahrenheit. Do you have any questions about this? You are not done writing a function if you haven't written your tests. I know, like on assignment 1, I gave you the tests, right? Because it's new. But you're lucky, right? You get to know if your code is correct before any TA or marker looks at it. You're going to know if it's right or wrong, because if it's right, well, the tests are going to pass. If the tests pass, you're very likely correct. I guess it's possible that you're wrong. You can cheese those tests to make them pass. But chances are you're correct. You're lucky. Not very many disciplines are like this, right? You will know if you're correct because, well, did it do what it was supposed to do? And I think I said this last time, but I'll say it again. If I haven't written the Celsius to Fahrenheit function yet, that doesn't matter. I can write the tests for the function I'm about to write before I even write the function. Because if a function that converts Celsius to Fahrenheit is correct, all of these tests will pass. Some people even do like test-driven development, where like this is kind of the idea. You write all the tests first, and then you write the code. Because when you write the test, it also has you kind of really thinking about all the different cases that your function needs to cover. Now at this point, it might seem like, what's the value in that? But remember, the functions that we're writing right now, although not trivial, functions can get a hell of a lot more complex, and they will as we go. But don't let that worry you, because that's where things actually start getting a lot more fun and a lot more interesting, in my opinion. Now, like I was saying a moment ago, if you wrote more tests or maybe a few less tests, and you were to ask, well, am I wrong? No, you're not wrong. You might say, like, well, why didn't you check more floating point numbers? Why didn't you check a negative floating point, a positive floating? Why didn't you check all these different? And you're right. Maybe I should have, right? There's nothing really wrong with being a little overkill with the tests, but you don't need to go that crazy. Knowing what cases should be covered in your tests, again, more of an art than a science. You just get a feel for it as you go. I'm going to say it. This is going to sound mean. I don't mean for it to be mean. You're going to suck when you start because you're not used to it yet. But the more you practice, you get better, like literally everything else in your life, right? It's not new. Now, in reality, at the end of the semester, we're going to talk about something called unit test. And unit test is perhaps a slightly more robust way of writing tests than the assertion tests. The assertion tests are very effective. And the unit tests are effectively just doing these assertion tests, just with a little bit more magic. And sometimes our code gets a little bit more complex where tests like these assert tests are very limited. We can only do so much with them, where this unit testing that we will be learning allows us to do a little bit more, a little easier. We will learn that. The reason we're not covering that right now is because there's a lot involved. You would need to learn a lot more before we can actually cover these ideas. But for now, these assert tests, not only are they enough, they are great. They are fantastic. They're not lesser than, they're just simpler. Okay. Any questions about testing? It is not about writing the code. It's about writing good code that's correct. If you write a function, I don't care. If you write a function that you demonstrate with assert tests that it's also correct, I now care. I'm happy. Again, I'm going to say it again. I probably said this last class. If you have a job and you're a programmer and you write a code and you go to your boss or your colleagues and you're like, here, I wrote this code, and you don't have assert tests, they're going to be like, okay, go away. I don't care. You're not done. You didn't write that function. You're not done yet. Write the tests. No one wants your code. No, it's not someone else's job to look at your code and be like, is this right or wrong? No, that's your job. If you write the code, you also need to have it come along with some little guarantee that it's correct. And that's what these tests are for. With these tests, you can't prove it a lot of times that it's correct, but you can get as close to proving it that people are happy, right? If you write tests, and if I look at your code really quick and I look at your tests, and everything looks pretty good with a quick eyeball test, I'm going to be happy. But if they don't have the tests, they're going to tell you to get lost. They'll laugh at you. They'll make you feel terrible about yourself if you don't write your tests. And I'll do the same thing. I'll make you feel terrible about yourself if you don't write your assert tests, because you got to. A function is not done if it's not tested. Always test. So what do you always do? Yeah, there you go. That was the whole thing. Write your tests. Easy peasy. And you're going to forget how to do it. But the good news is this web page exists, and you go, how do I do it? And then you go, oh yeah, that's right. That's how I do it. Any last questions about these tests? So raise your hand if you're going to write these tests now. Everyone put your hand up. Otherwise, I'm going to make fun of you. Put up your hand, everybody. Keep it up. I want to see. Put your hand up. Whose hand isn't up? Your thumb, that's good enough. Your thumb up is good. Good, so you're all committing to writing tests. That's great, good. So if you don't, I now have license to make fun of you, right? Yeah. All right. Now, type hints. If I run this code, and I've shown you this example several times, if I go write this code, add together, and I say 1, and I say 1, I get back 11. Why did I get back 11? Well, because 1 plus 1 is obviously 11. Because, well, the string 1 plus the string 1 is 11. And if I look at this code, it says calculate and return the sum of the two provided numbers. That's really not what happened there. Because the issue was, there's nothing wrong with this function. Would you agree? The function did exactly what it was asked to do. This function will, if you give it two numbers, it'll give you the sum. The issue here wasn't with proving correctness of your function. The issue here was how that function was used. It was misused. And this is like an issue with testing. You can test your function all you want, but some asshole can come along and misuse your function. That's on them, though. That's not your fault. That's their fault. In some programming languages, it's impossible to make this type of mistake. In Python, it's easy to make this type of mistake. But there's one thing we can do to help protect against this happening. Usually, people misusing function, it happens in good faith. Raise your hand if you use the sine function, but you were expecting it to take degrees. Right? I've done it. Well, I misused that function. That was my fault. It wasn't the function's fault. It was my fault. There's something I can do in this particular example to help make it a little clearer to the programmer. Because a lot of times when you're misusing a function, you're not doing it on purpose. You're not going to say, yeah, I'm going to mess this up. To what end, right? If you're misusing a function, it's by accident. So what we can do is add a little something to our code to help make it a little clearer about what the types of the things should be. And this is where type hints come in. What this says is, you take a parameter a and b. A should be a float. Now I said float, not int, because like float is like bigger than int, so it'll work with both cases, right? It takes A, which is a float. It takes B, which is a float. Anyone want to take a wild guess what the little like arrow float means? Someone yell it out. Negative float? What? Negative float. Oh, I see, because of the... No, that doesn't literally mean like negative greater than. It's supposed to be like the... Just get it out, man. Just get it out. What do you think? Exactly. The return type of this function is a float. I give it 2 floats, I should get a float back. So this then tells the programmer, there you go, what a guy, right? Helping you out. This tells the programmer, oh yeah, okay, this function, it's expecting 2 floats. And in fact, even when I go down here, like check this out. If you haven't noticed this already, look. Look at that. What do you see written there? That little pop-up. What do you see? That's the doc string that was written. Now here, you're like, okay, oh, that's great, but it's also literally right above. But consider this. Where do you think that came from? It's print's doc string. The absolute values doc string, right? So that's another reason we like to write the doc strings, is these environments that we program in, we'll use them to be like descriptive. Like if I'm down here, I wrote this a billion lines ahead, right? And I go down here and I say add 2 numbers. And I see, oh, okay, A and B. Oh, but they're supposed to be floats, right? You could see even in that doc string that it's supposed to be a float. It takes a float, returns a float. So it makes it even clearer to the programmer that these are supposed to be floats. Code is not for computers, it's for humans. Compiled or interpreted, whatever word you want to use, code that is turned into the zeros and ones that a computer will run, that's for computers. Code is for humans. And this makes your code that much more clear. Would you agree? Now you're like, what type is A supposed to be? There's no like, well, oh, it returns the sum, so presumably they should be numbers, right? No, here you go. Oh, it's a float, it's a float. I know it's supposed to be a float. 4. And look, it even like, look, the little like blue emphasis even changes to where it is, right? Which one it is. It lets you know. It's pretty cool. So the type hints are there to say to the programmer, this is supposed to be a float. But be warned, everyone pay attention, this is big. In other programming languages, when you're explicit about your types, if I came along and was using a function that was expecting 2 floats, and I gave it 2 strings, and I were to go hit run, it wouldn't even run. The program would say, no, I'm not running. You said I am a function that should take 2 floats. But you gave me 2 strings. I can't do that. I'm not going to run. And that's a good thing. If your code is wrong, you don't want it to run, because then a bug that you might miss comes along. Imagine this is critically important code, the add together, and you print out the result, and you just assumed, maybe instead of inputting values, right? Maybe it had some sensors that it was reading. And it's always, you assume it's printing out the sum, and you see a number like 11, and you're like, oh, okay, great. So those sensors read things such that the sum was 11. Okay, that's important. But it wasn't. It was only 2. It's better that that code doesn't run than to run and be wrong. Here's the bad news, though. In spite of having type hints, Python will still work. It'll still say, oh, no, it won't because I messed up. X, Y. Python won't protect you. This is an example of Python being, oh, look, it's flexible. You could do what you want. And you tripping over with all the extra rope it gives you. You got tripped up on it. So Python, a lot of people think like Python's flexibility is a really good thing. I mean, yeah, but you're bound to trip yourself up on it. A lot of times those constraints really help simplify things. So all the type hints do is hedge against the person using your function, whether it's you or somebody else. All it does is protect against them using it incorrect. But I can't guarantee it. So even though the type hints are there, the type hints are really just there for like documentation of the code, self-documenting code. It won't enforce anything. Now you can get like static type checkers and everything for Python. We're not going to do that. That's kind of a pain to get set up and run and everything, where it will do all that for you. But we're not using that, so just be warned. From now on, whenever you write a function, pay attention. I need all eyes here because this is very important. Whenever you write a function, you better have your docstring, you better have your tests, and you better have your type hints. Okay? They got to be there. I'll give you an exception on the tests, right? If on the test you're writing a test, I'm not going to expect you to write assert tests because the assert tests aren't even going to run. Unless the question is like, write some assert tests for this function, well then yeah, do it. But if I asked you, write a function to do X, Y, Z, I'm not going to expect you to write a docstring. If you don't include type hints, I'm not going to care. And if you write assert tests, all you're really doing is opening yourself up to making a mistake that I'm going to see. So just don't write it. You're better off to not give me more to criticize. Cool? Yeah? Awesome? Happy? Any questions at all? Type ins. Yeah, this is just what I said. So this is me showing what you get. What you don't get is it'll still not work. Great. So yeah, yes?
On like, when you were scrolling by, I saw the thing that said like, using the doctrine of like power type stuff.
Here?
Like, if you just go.
Oh, here?
Yeah.
So that's something you could actually add to your docstring. You could say, there's a lot more you could add to make it clearer. You could say type of A is a float. To make it even more clear, right? R type for return type. You could add these. And you know, whatever you add to your docstring will be there. You can. You don't need to worry about it because they're going to be like up in like where the function's starting to be declared. But that's what that means. Good catch. You can add it if you want. Other questions? Everyone's good? Oh, okay. Oops. All right. Okay. Let's do an activity, but I want to be very clear that I want you to do exactly what it says. Using only what we have learned so far. So if you start doing stuff we haven't learned yet, you're cheating. Only with what we've learned so far, your job is to write a function called smush. It takes a number that checks if the number is positive or negative. If it's positive, return the number divided by 2. If it's not positive, just return the number. Okay? That's your job. If I gave this, let's think of what the test would look like. If I gave you 4, what should I get back? If I gave you -4, what should I get back? If I gave you 0, what should I get back? 0. If I gave you 80. If I gave you 80, what would I get back? 40, yeah. So that's the job. Write that function. I'll give you a few minutes to do that. Anyone get it? No, not yet. All right, keep thinking. Anyone get it yet? But it's so simple. Why can't you get this? Well, you can't get it because I'm being mean. It's not possible. You can't do it yet. We have no way in our code to make a decision. There's no way for us to go, well, do this or that based on some information. There's no decision-making process yet. But we can fix this. We can by saying, okay, if some condition, do this. And then sometimes even we could say, and otherwise do that. But let's have a quick look here. Conditional expressions, Booleans we already talked about when it came to logic, where we could check if things are true or false. We use Boolean operators that, like the binary ones that were like true, or sorry, like and or. There was the unary binary operator, the not. Then there were the comparison operators where you compared values and you got back a Boolean. So we learned about Booleans as a type and some operators already. But Booleans allow us to do a lot more. Well, I mean, Booleans themselves are just the Booleans, but we can make use of these Boolean values to help us make decisions. The key is to tell Python that if some condition is true, do something. And here's an example of smush. I think I've already got the code over here. And there we go. Have a look at that function. Now, just like with the asserts and a lot of things in this course, remember, the if doesn't really care about the a number greater than 0. The if cares about what a number greater than 0 evaluates to. So the if only works on a Boolean. It only works on a true, false. One of those. If the expression evaluates to true, then the code inside of the if statement, inside being it's indented. Just like with a function, when something is part of a function, it's indented. If something's part of an if statement, it's indented. And then when we're done writing that if statement, guess how we get out? Anyone want to take a wild guess? Backspace, well, that's how you would do it. Come on. How do we get out of a function if we're done writing a function? No, not the return. I mean, yes, it's there. I'm thinking of me writing the code. I'm writing the code, and now I want to write code that's not inside the function. How do I do that? Unindent. Genius over there. You unindent. So you indent the code that's in the if, and then if you're done, you don't want to be writing code inside the if anymore, well, you just unindent, like in this example. So let's take a moment. You've never seen an if statement before, potentially, before today. And let's quiz you. I put in the value 4. So everyone wake up. I don't want lackluster participation here. I put in the value 4 on line 15. We're line 15 right now. And I know I was bad. I didn't write the assert test here. I should have. I put in 4. What value does the number take? Everybody. Let's start. We jump to line 1. What value does the number take? The parameter. No, 4's correct. I'm just disappointed in the participation. Is there something wrong with this section versus the other section? Is it too early? Is 11 a.m. too early? What's going on? Wake up. We're on line 4. We call the function smush. So we jump to line 1. There's a parameter called a number. What value does it take? 4. There's all comments. We skip all that. Now on line 10, return value. What value does that variable take? 4. Then we look at the statement. Is a number greater than 0? Well, what is a number? 4. So is 4 greater than 0? Who said yes? Try again. Much better, much better. It's true. So if true, we go and we actually run the code inside of the if. So we go, and now we're on line 12. Well, what value does return value currently have? 4. So what's 4 divided by 2? So where do we put the 2? Back into return value. We're done the if statement. There's no more lines of code there. We'd go to line 13. What value do we return? 2, because that's what return value has. Yeah. That's it. That's all we got. That's what the code's doing. You're already experts with if statements. Let's try again with -4. We're on line, what line is that? 16. -4, we jump up to line 1. What value does the parameter a number get? By the way, if you think for a moment, the reason I'm going through this line by line is not because I'm trying to be like baby you or anything. It's because going through the code line by line, like if you think I'm doing this for my benefit, if you think I'm doing this to baby you, it's like, oh yeah, we can follow line by line. Going through the code line by line and understanding what it's doing is this course. So me doing that, like, no, this is what we should be doing right now. So a number takes what value? -4. We jump to line 10. What value does return value get? -4. So now we ask the question, if a number is greater than 0, well, what's a number? Is negative 4 greater than 0? False. So if false, we skip that block entirely. We jump down the line 13. What value gets returned? Negative 4, the value that's stored in the variable return value. That's it. We now have the ability to make a decision. Now, it's not trivial, but thank God the syntax is relatively simple. If true or false. We've got the expression there. Yeah. Now, let's take a moment and talk about this code. You might think to yourself, you know, I use 2 variables here. I could have rewrote this. I could have wrote this without using 2 variables, right? Like I could just say, I can get rid of this. And it works just fine, right? But I did it with 2 variables. Who wants to tell me why I did it with 2 variables? That's not why, but that's a side effect of what we get. To make it clearer. There's 2 variables. If you think, but yeah, I could have done that with 1. Yeah, you could have. But now, you know, the value of a number was never changed. That was the parameter. Return value, it's clear which one's which. I mean, on line 11, I could change it. Why didn't I say if return value is greater than 0? It would effectively, it would function the same. They both have the same value. But remember, what is it that I want to check? A number. Is the number it got greater than 0? Now, I know return value has the same thing, but the code is using the variable that the intent, like what was actually being compared here, what was being checked? A number. I know the actual value is the same inside return value here. I know. But to me, this code is just a little bit clearer about what its function is and how it's functioning. I find this clearer the way it's written than this. Even though it functions the exact same way, even though return value and a number are equivalent, they always will be by this line of code, I find it clearer because it is the value, the parameter that was actually like the thing that I cared about comparing. Even though the value is still the same in return value, it means the same thing, but this is clearer. Oh, look, I do actually have tests. Oh, good for me. Great. Now, and does anyone see anything in here that they have questions about? No, all of this is just, yeah, okay. Now, all of this is just emphasizing the point that I'd kind of already said, but I'll say it again. Give me 1 second here. Is the Boolean operators, the comparison operators, and even the assert and the if, they don't care about the statements on the left and right-hand side or the right-hand side if it's an if. They're not concerned. This if doesn't care about a number greater than 0. It ultimately does. The if, in terms of how it's functioning, only cares about what that expression evaluates to. It's going to evaluate to true, false. One of those 2 things. When Python sees if true, then it runs it. It might sound, if to you it sounds like, yeah, obviously, I get that. It's being evaluated and then it works on what the actual value is. If it's obvious to you, great. But this is a huge cause of issue for new programmers a lot of times. They think the if is working on the entirety of that expression. No, the if only gives a shit about what it finally gets evaluated to in the end. Everything gets evaluated to the true, false, one of those two values. And then the if cares about the Boolean value that it gets evaluated to, not the expression itself. Same thing goes with and or nor. If I've got this long expression over here, a long expression over here, and I have an end in the middle, the end doesn't care about the expressions. It only cares about the Boolean values they actually evaluate to. So you had a question.
Yeah, I probably guessed the answer to this, but you see the line there on the right side?
This here, yeah?
Yeah, I'm just trying to figure it out.
I'm not sure what this one is particularly set to, but in a lot of like programming environments, you can set like, what is like the total space we want here to ensure that your lines don't get too long. My guess is this one by default is if I were to print, this would be like the end of the page. So if I had words that I keep going, if I were to print this, my guess would be the printer would be thrown off by this and it would go to like a new line and it would get all messed up. That's my assumption. That's what the default is. I'm guessing also if we go into the settings, we can look in the editor. Default, vertical ruler column, 80 characters, yeah. So it's 80 characters wide. Anything beyond that will be past that line. That's all it is. Any other questions? Yeah.
When I do the part at the top, right, that decides not to be a float, it just doesn't work.
All right, well, you probably got some funny syntax thing wrong, but if anyone has any questions with their code or anything and they need some help, be sure to come to student hours, which is posted on the website. So if that's something you're stuck with, by all means come to student hours and we can happily get that figured out. All right, see you all later.